Hi everyone. Today we'll take a look at a really small concept, but it's an important one, and oftentimes it does and can pop up. And it's oftentimes also overlooked because you think it's a subset of what we've originally studied. But I thought, you know what, it's not a bad idea to make a small video on this section as well. So this is what we're going to cover is selection of at least one object. So at least one object. You can think about it like that. So yes, it's kind of like a special case from the selections video that you may have seen. It's I think my second video, yeah, or my third video. It's based off of that, but it's something that again you can miss because you can get so focused on using the formulas that you might overlook it. So I just a few example questions, and I think it's important that we address them. Okay, so we have the first example here is find the number of ways of selecting at least one fruit from five different fruits. Okay, five different fruits. So we have, fruit A, fruit B, fruit C, fruit D, and fruit E. So there's two methods actually. I'll create, like a division here so we can discuss both methods. So method one, I'll do it in green, is a simple formula waste. So there are five fruits. We have to select at least one of them. So either we can have one fruit, two fruits, three fruits, four fruits, or five fruits, but we can't have zero fruits, right? So we can have 5C1, 5C2, 5C3, 5C4, 5C5. We can't have 5C0 because 5C0 means you have five options and you're choosing none of them, which isn't possible. So the sum of this is your answer. Now, if you already know something, so basically you have to subtract or you can think of it as I'm adding 5C0 as well, and then I'm subtracting 5C0. Think of it like this, right? In that situation, if you remember your binomials, if you haven't, it's okay, we're covered in the next playlist. This part that I've put in parentheses in yellow, that's the same thing as 2 raised to the power 5. And 5C0, well, that's just 1. So what we have is 2 raised to the power of the number of options because we have 5 fruits minus 1. That gives us 31. That's our answer. You can directly, you can just do directly like this and you could get the answer. That's also fine. That's a shortcut, you can say, but that only works when every single item is distinct. We'll look at an example where we're gonna have, 3 mangoes, 4 oranges, 3 bananas, something like that. Then this approach really doesn't work. It fails. Now let's look at another situation, or let's look at another way to solve this question before. Let's say you have each fruit, okay? So you have the option to either accept it or reject it. 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 So you have a total of 2 options for A, 2 options for B, 2 options for C, 2 options for D, and 2 options for E. Now, there's an issue with this. There's one option where all of them are rejected, so we have to remove the option. Now, if you notice, this is the same thing as 2 raised to the power 5 minus 1. I hope that makes sense. Okay, again, we're going to get 31 ways as our option, as our final answer. So this was probably the easiest of the easiest. Let's take a look at a slightly trickier option. Okay, so now we have selecting 3 mangoes, 4 apples, and 5 bananas. We can't do 3 raised to the power or 2 raised to the power 3 minus 1 and all of those things. That's not possible. So we're gonna have to use the second method, the one that I've done in purple here. Okay, so if we have 3 apples, so let's 3 mangoes. So we're gonna have, let me do it like this. Let me take orange and let me put mango, mango, mango. That really doesn't look like a mango, but you get the gist of it. uh Apple, 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 That doesn't look like an apple either. And then bananas. Banana, 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 banana. That's like a whole branch of bananas. Okay, you're gonna have to pick one of them. Oh, sorry, there's 5, so one more. Okay, so now let's break it apart. So we have 3 options. Either we can select all of them, or one of them, or 2 of them. So we have three possibilities, or none of them. So we actually have 3 plus 1. Either we select 1, 2, or 3, or none of them. That's why that's the 1 is there. Similarly, we have 4 plus 1. And we have 5 plus 1. Now we can multiply all of them, so we get 4 times 5 times 6. Well, that's 120. Now we have to subtract 1. Why? Because this includes one of the possibilities where not a single fruit is selected. So that gives me 119. I hope it makes sense. Again, there is no formula to solving these questions. It's intuitively done. You don't really need a formula. As you can see, I've done these questions intuitively once you get the gist of it. And that's about it. I don't think the IB, confuses you too much on them. It's pretty straightforward. All right, okay, so the final question in this video is, a room has 10 light bulbs, which can be switched on independently. In how many ways can the room be illuminated? I want you to pause the video and give this give this question a shot. Try it out. If you have solved and if you've understood what you've done in the previous 2 questions, this question should be a breezer as well. Okay, assuming you've given a go at it, I'm going to first give you the final answer. That's going to be 2 raised to the power 10 minus 1, which is 1024 minus 1, which is 1023. That's your final answer. If you've got that answer, great. If not, let's break it apart. There are 10 light bulbs, right? Let's draw it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Forgive me for the pathetic drawing skills. So now we have the option to illuminate or not. Turn it on, turn it off, turn it on, turn it off, turn it on, turn it off. And we have 2 options for every single light bulb, right? So there are 10 light bulbs, there are 2 options. So that gives me 2 being multiplied 10 times, right? 10 times. Finally, it's going to give me 2 raised to the power 10. However, for the room to be illuminated, or for it to be considered illuminated, that means at least 1 light bulb must be turned on, right? So there's going to be this one situation where none of them are turned on. And that's the one that we're subtracting again. So this is why we do 2 raised to the power 10 minus 1, giving us 1023. I hope that makes sense. This was a fairly short video. I'm sure you can kind of, extrapolate the situation if you want. I can give you sort of formulas as well. If you, in a first situation, if you have n distinct objects, then it's basically 2 raised to the power n minus 1. If you have something of n plus p plus q, like I had the apples, bananas, and mangoes, if you have something like this, then you do n plus 1, p plus 1 times q plus 1 times n plus 1 minus 1, kind of like that. That's the formula I used. Or if you have, let's say, another third situation where you have n similar objects, say n of the same fruits, or sorry, n total fruits, or n total objects, p are alike, q are alike, and remaining are distinct, right? Remaining are distinct. So in that situation, you can do p plus 1 times q plus 1, n minus p minus q, 2 raised to the power n minus p minus q, and then a minus 1. It's the same thing. I'm just extrapolating it based on the specific conditions we have done in this situation. Again, fairly short video. If you can understand what we have done here, broken down how I've broken down the question, even if you get a slightly more complex question, the way of solving or the approach of solving these questions remains the same. So this is all for this video, and I'll see you in the next one. Bye-bye.